For thousands of years, human clothing has operated under a basic physical constraint. Once a thread is dyed, woven, and cut, it stays exactly that color and shape for its entire life cycle. Because static clothes cannot adapt, we purchase separate items for every slight change in weather or social context. This leads to a cycle of overproduction, where millions of tons of garments are discarded as they fail to meet the shifting needs of the wearer. In 2026, AI is moving away from digital screens and into physical textiles. The processors that powered virtual models and forecasting algorithms are being embedded directly into the fabric itself. These generative wearables allow a single item to adapt to multiple scenarios. Instead of a static object, the garment functions as a reactive platform that changes its properties based on the environment. To understand how this works, we must treat clothing as a dynamic, fully integrated computing platform rather than a passive material. The outer layer of this platform serves as an aesthetic interface. It replaces traditional chemical dyes with a programmable visual display system. This cross-section shows the mechanics of chameleon textiles. Micro-LEDs and flexible color-changing polymers are woven into the fabric. These nodes receive instructions from a central microchip hidden in the seam of the garment. A simple vocal prompt to a smartwatch, requesting a more energetic look, triggers the processor. Within seconds, a neutral gray blazer shifts its polymers to display a vibrant, pulsing floral pattern. Beneath the display layer lies a sensory network that acts as the garment's nervous system. Conductive threads running through the interior lining track heart rate, respiration, and posture. These flexible sensors maintain continuous contact with the skin, gathering biometric data without the need for bulky external devices. The onboard AI interprets these signals to trigger physical responses. If the sensors detect a spike in stress levels, the processor can activate cooling elements within the weave to lower the wearer's body temperature. The fabric interprets your biological signals and actively manages your physical well-being throughout the day. To alter structure, garments utilize shape memory alloys, or SMAs. These threads contract or expand via electrical currents, changing weave tension. Guided by environmental triggers, when sensors detect water, the thread snaps tight, closing fabric gaps to increase water resistance. This allows for generative draping. During a rainstorm, a trench coat automatically shrinks its hemline and cinches the cuffs to keep the wearer dry. The garment sustains itself through kinetic charging, capturing energy from the wearer's movement. For more power-intensive functions, the fabric supports wireless charging, drawing power from ambient light or charging pads. Connectivity is handled via embedded NFC tags. Each piece of clothing carries a digital passport containing its manufacturing history and its place in the Internet of Outfits. This connectivity allows separate items to synchronize. Your shoes can tell your pants to match their color palette, or your sleeve can automatically share your social media profile with other attendees at a networking event. Individual garments have become interconnected nodes in a personalized technology ecosystem. Beyond individual utility, this architecture addresses the systemic resource waste of traditional garment production. This bar chart compares the resource consumption of a standard 50-item wardrobe against a single generative system. Because one garment can change its color and shape, it replaces the functional need for dozens of separate purchases. These garments are built for circularity. Most generative fabrics are woven from biosynthetic materials that are designed to be fully recyclable at the end of their functional life. The engineering ensures that electronic processors and batteries can be unclipped and removed. This allows the fabric to be washed or recycled, while the high-value technical components are reused in new garments. Static, disposable clothing is becoming obsolete. The future of the industry depends on designing sustainable, reactive interfaces that adapt to the wearer.